So when somebody first asked me to do this talk, I said, you do realize that one of the premises of evolutionary architecture is we don't know how things are going to change. And so you need to design your architectures to respond to whatever change happens. And I was reminded as I was putting this together, approximately 10 years after the iPhone was released, I had a journalist, and I will tell you that as CTO, the thing I hated the most about my job was talking to the press. Apologies to anybody in the room from the press, but no. But they asked, what's it going to be like in 10 years? And I said, do you realize it's been just about 10 years since the iPhone was invented? Now, do you really think anybody can predict that far out? And they assured me that they were thinking more about 2 to 3 years out. So I thought, okay, I can probably handle that. But my crystal ball is still broken. I am making no promises about any of the predictions that are in this talk. But I do want to start with kind of the basics of evolutionary architecture, because that also does play into how I think things are going to change. Now, one of the most important things when you write a book, when you coin a new area, is you've got to figure out a name for it. And I'll talk a little bit more about the name, but we did end up with evolutionary architecture. You also have to define it. And defining terms is really hard, because you want to make sure you got all of the nuances. You want to make sure that you haven't left out an important part of the definition. And there are 3 critical pieces in this definition. Evolutionary architecture supports guided, incremental change across multiple dimensions. Guided simply means there is a goal. Incremental change means we want to be able to support changes in increments. And, of course, that's not only the whole basis of agile software development, but it allows us to really think about how is it that I get these changes in as safely as possible. Because we're talking pretty fundamental changes here. When I first started talking about this stuff, I would have people come up to the stage afterwards and they would whisper, don't you think you're being professionally irresponsible talking about evolutionary architecture? It's the rock. It is the foundation. They don't say that anymore, because I think the industry has come to terms with the fact that these things do have to change. That rock is not nearly as solid as we wanted it to be. And so we need to be able to change this stuff. So there are a few ideas from the broad scope of evolutionary architecture that I want to talk about. And the first one is why the name evolutionary. And the first time I heard Neil Ford talk about this, he called it emergent architecture. And he had very robust discussion about how that was an awful name. I have no problem with the concept of emergent design, because good code is good code and bad code is bad code. It doesn't matter if it's retail code or risk code or website code. Good code is good code and bad code is bad code. There is no such thing as a universally good or bad architecture. One of my favorite examples of this is a trading system I worked on. Now, you all hear trading system, you think low latency, high throughput. In their wildest imagination, they would have 100, maybe 200 transactions a day. The architecture of that trading system was completely different. There is no such thing as one good architecture. And so you can't just talk about emergence, because emergence is just this, we're going to go where we need to go sort of thing. That's where guided comes in. One of the first things you have to do is establish what are the critical architectural characteristics that will determine the success or failure of my system. And that's what guided is all about. Now, the other one I want to talk about is adaptive. because you can kind of say that's what we're trying to do. But when you say the word adapter, or however it translates into your native language, what do you think of? You think about an adaptor, or however that translates into your local language. And you can't write an adapter unless you think you know where the change is going to come from. And what happens when you do that? You write more code, which means you have more bugs. You have more code, so you know it's harder to understand. And chances are, you've made it harder to make the change ultimately you have to make. So don't try to guess. No, this is not, you're going to throw out everything you understand about the domain. You've got all the same kind of arguments here as you have with Yagni. This is not a license to ignore what you know. It is, though, that you shouldn't try to think you know something that you have no basis. So how does guiding work? And it works through a notion called fitness functions. And there's absolutely nothing new with this concept of a fitness function. If you've ever put something in a build that says fail the build if the cyclomatic complexity is greater than X, you've run a fitness function. If you've ever put in an alert that says if my CPU utilization gets above this level, send an alert, you've written a fitness function. The advantage of this notion, though, is it unifies a huge array of concepts. What do the ops people want to go live? What are the security requirements? What are the performance requirements? All of those things, by capturing them as fitness functions, number one, you are making them objective. Because the only thing that matters about its fitness function is you and I will never disagree on whether it passes or not. So maintainable is not a fitness function, because we can disagree on that. Cyclomatic complexity, respect for layering standards, all of those things that play into maintainability can be. And finally, how do we operationalize it? And there are two aspects to this. One is how do we get the functionality in? And there's all kinds of literature around things like feature flags on how we can incrementally introduce new features. The second aspect is how do we actually get the thing into production? Now, all of those people who are whispering about my professional irresponsibility, I will agree with them. If you don't have the right kind of discipline in your build and automation, you shouldn't be trying a lot of these things, because you've got to know when I'm deploying something into production, what kind of environment it's going into. And by the way, this is old. So for example, you won't find observability in here. There are people who will say we need to optimize for all the ilities. They have no idea what they are talking about, because you can't. Many of these are mutually exclusive, which is why you have to pick the ones that matter. Low latency wasn't something my trading system cared about. They cared about never, ever losing a message, because each one of the trades were worth billions of dollars in $2,000. So even more now. So not all of these ilities are created equal for your particular system. What we are proposing is, in fact, a new ility. And just like all of these other ones don't apply in all situations, evolvability doesn't either. One of my least favorite following on a talk was there was a scientist from the Jet Propulsion Laboratory in the US who was giving a talk about a robot. And he actually ended his talk with the robot dancing. Try to follow that. But part of what his talk was about was he was talking about how they took advantage of the cloud to be able to analyze a data set that had come back from one of their rovers. The data set was only going to come back once. That code didn't need to be evolvable. You were never going to have that data set again. So this is no different than any of the other ilities. You might care about it. If you're working in a large enterprise with a very messy integration scheme, you probably do care about it. But you want to consider it just like any of the others. So I want to talk about two different aspects of this. First, principles. And then I'll talk about how I think those principles might change. And then I'm going to identify a few practices and how, over the next few years, those practices might evolve. So here are the principles. Last responsible moment, when we make decisions. The first question I get asked when I talk about this is, how do I know when that is? And my answer is, you look at your fitness functions. Your fitness functions are going to tell you what are the consequential architecture decisions, and you use that to guide. Now, of course, if you work in an enterprise where their procurement cycle is 9 months long, you might not have as much optionality as some other organizations might. Next thing is to both architect and develop for evolvability. And in a nutshell, developing for evolvability means caring about readability and understandability. You cannot change something you cannot understand. So code quality does matter. Architecting is a little bit different. Part of the way I look at this is how closely do your little c components, I haven't come up with a good word that isn't a component, but I'm not meaning some big component-based architecture, but your boxes, how closely to the boundaries of your boxes correspond to how the users of your system think about what the business does. I think part of why we got into so much trouble with service-oriented architectures is we constructed those services around programs, not concepts. So draw the box and make sure it corresponds to something that makes sense within the context of what your organization does to make money. Because the people who are going to be asking you to do things, that's their mental model, and those are the boxes they're moving around in their head. And if your boxes correspond to their boxes, it's going to be a whole lot easier for you to move your boxes around. Pastel's law. Simply put, be very careful with what you send, because you are making a commitment, potentially to people you don't know about, that you are going to provide this information. Be liberal in what you receive. Big asterisk, don't do something stupid that opens up a security hole. But if you're getting an address and all you care about is the postcode, don't validate the address line. If they want to split it or merge it, it shouldn't affect your code. We cannot guarantee that there will not be breaking changes, but you can make it that the only breaking changes are the ones that have to be. Architect for testability. I'm from Thoughtworks. I have to talk about testing. But one of the things that we found over the years is if you think about how testable a system is, you actually end up with a clean architecture. Going back to how we draw the boxes. If you have a test name that starts over here and says, do this and this and this, and possibly this, and as a result, perhaps this will happen. You have no idea what that component is actually trying to do within the context of how your business makes money. It also steers you away from things like, quote unquote, smart pipes. You want dumb pipes and smart endpoints, because then you can rearrange the pipes however you want. If you've got logic on those pipes, they're making assumptions about what their endpoints are. And finally, Conway's law. It never takes long to get to Conway's law when you have architects. But fundamentally, Conway's law says your system will reflect the communication dysfunction of your organization. Now, that's not how he phrases it, but that's how it works out. I often look very intelligent or magical or something. I walk into a client, and we go to lunch. And then I'm talking to the VP or whoever, say, that integration is broken. I said, how in the world do you know that? You haven't looked at anything yet. Because the tech leads at lunch walked by each other like this. If the people don't talk, the systems will not talk. That's fundamentally what this is about. You have to, if you want to change your system, you have to make sure your organization reflects that. So how might these principles change? I really don't think much is going to change about either Pastel's law or the last responsible moment. The caveat to that is there are going to be additional integration points that are going to look oh so alluring. We had one client who did absolutely the right thing when they bought a COT system. They said, we're going to change our business process to match what the COTS wants to do. And that way we can upgrade. And then what happened? A major upgrade came along. And they realized that there were 87 reports that directly access the database. Remember what I said is you don't necessarily know who's relying on that information? It took them a very long time to upgrade, not because they did the wrong thing with their business process, but they didn't keep control of their integration points. How is that going to play out in things like IoT systems, things of that? There are going to be new instantiations of how Pastel's law can go wrong, but I don't think it's fundamentally going to change its role. Architecting for evolvability is a little different. I actually think part of the reason we're seeing so much creativity now with respect to architecture is because of continuous delivery. For those of you who have the proper amount of gray hair, you might remember what deployments used to be like. And can you imagine going into an operations manager and saying, oh yeah, so we split this thing up that used to be one deployment into 85. Piece of cake. You would have been fired. With the level of automation that we have, we can start thinking more about what is the right kind of architecture that will allow us to express the system we're trying to express. And so I think we're going to continue to see innovation in architecture. And we're going to have to think about what do those innovations mean for evolvability. For example, some people will say the only truly evolvable architecture is microservices, and I believe that is a false statement. Some are more evolvable than others. I also think as we get into more digital twins, autonomous vehicles, we're going to want to think again about the implications of how heterogeneous these architectures are. Years ago, heterogeneous meant you had a really dumb client and a big honkin' server. Well, what constitutes clients now are far more powerful than those big honkin' servers were 30 years ago. But that doesn't mean there's not still a disparity. And that doesn't mean we still don't have to think about what are the communication payloads. So I think these systems are going to give us different things to think about, and that will give us different implications for what it means for that kind of system to be evolvable. Another very interesting area, I think, is platforms and platform thinking. More and more people are taking advantage of platforms at various levels. I'm going to ignore the business model platform. Sometimes it's just infrastructure. Sometimes maybe it's an API layer or a business capability platform. What it means to be evolvable in those contexts are very different. And as our thinking around platforms evolves, what it means to be evolvable, I think, is going to change as well. And then, of course, there's just XR. We don't even know for many business problems, what would it mean? I remember having a conversation with somebody about financial services. Oh yeah, we're going to open a branch in the metaverse. And it's going to be a virtual building, and it's going to have a virtual desk, and it's going to have an avatar of a VP of lending who sits behind the virtual desk and waits for virtual customers to come in. You've got to be kidding me. But we don't know what the right business process looks like. Perhaps there isn't one. And all of those things are going to affect how we think about constructing AR systems. And I managed to go over 20 minutes without saying the words AI. When was the last time that happened? But that is obviously from the perspective of development. What is the impact of AI-assisted development on what constitutes good code? The thing that terrifies me is now we have the ability to generate millions and millions of lines of garbage. How are we going to keep track of that? I do think we also have to consider the low-code and no-code platforms are so much better than they were 20 years ago. They're still making wild claims. You can implement anything in my no-code platform. Well, perhaps you can if it's Turing complete, but that doesn't mean it's wise. I did see somebody once implement a text editor in Excel. Yeah. One of the interesting things we've been seeing a lot about is automating compliance. And I think we're going to be seeing innovations in how we actually use things like fitness functions to help with our compliance burdens. And this last one is probably just a wish, but maybe, perhaps, we'll get better code quality metrics. We're still a long ways away from having a good set of metrics. It's a whole lot better than it was, but I can always hope. I think we're going to see increased reliance on observability, testing, and production, many of those things, and we'll have to think about what that means in the context of fitness functions. There are things called dynamic fitness functions. The most interesting one is actually the simian army. And if you think about what it does, everything that's implemented in the simian army, nobody has to think about with respect to a code review or anything like that, because it just will get kicked out. Another thing, and we're already starting to see this, when we started working on the second edition of the book, we put out a plea to all Thoughtworkers, send us your fitness functions. And we got some really interesting fitness functions. And as more people start to think about, okay, how can I actually turn this thing that I want to make sure remains as an architectural characteristic, how can I actually express that in a way that doesn't fall into the maintainable category? I do think we're going to see increased use of AI, potentially artificial immune systems, to help us keep our systems more robust. I mean, let's face it, the attack surface that we're giving to all the bad people out there is just expanding. And so we're going to need to figure out more creative ways of how to protect our systems. And then there's still a lot we have to understand about how do you actually test machine learning models, things like that. And for Conway's Law, I think the big one is hybrid work. How is this going to impact that? Okay, so practices. Evolutionary database design. I've been dealing with development teams at Thoughtworks for a long time. And everybody always says, well, it's fine for the developers, but I'm a business analyst and I need to be able to flesh out my whole use case. Or I'm a designer and I need to be able to flesh out the holistic design before I get started. And of course, as a tester, you're not going to ask me to test something that you're going to deliberately change, are you? The people I think who always had the best arguments were the DBAs. Because as soon as something is in production, If you want to change the database, you need to do data migration. And it sounds so simple. You've obviously experienced just how simple it is. Being able to safely migrate your data with as few landmines as possible is a critical part of having an evolutionary architecture. Very often when Neil and I give this talk, we say, if you take one thing away from this, go buy the book, Refactoring Databases. We've in fact told the author he should reissue it because the title currently is Refactoring Databases and the subtitle is Evolutionary Database Design. And we've told him you should just reissue it. Evolutionary Database Design, Refactoring Databases. They haven't done it yet. Contract testing. What contract testing allows you to do is do as much independent work as possible. So I have a service, and it uses one of Fausto's services. I have another service, and it uses one of Eric's. And we exchange tests to document the assumptions we're making of each other. And then we ignore each other completely until a test breaks. My test with Fausto breaks. I continue to ignore Eric. And we have a discussion on how I'm going to change or how he's going to change so that we can implement my new functionality and still have our tests pass. And then we go back to ignoring each other. And Eric didn't have to know anything about this. Choreography. This one is the most controversial on this list. Much like microservices, you want to think about, is the trade-off of increased evolvability worth the increase in complexity? Because there are simply errors that can't realistically happen in an orchestrated system that can if you use choreography. To briefly describe this, in an orchestrated system, you have a conductor, and everybody's looking at the conductor, and everybody's in lockstep. You also have a single point of failure. If the conductor falls off the stage, everybody stops because they don't know what to do. Choreography, on the other hand, is like a dance performance. Each of the individual actors know what they're supposed to be trying to achieve. And if I try to make a graceful leap and my person has fallen down, it's like, I better not leap because there's nobody there to catch me. And it's my responsibility to figure out, okay, how do we move past this failure? It is significantly more evolvable to have a choreographed system because you've got the logic in, again, those endpoints that you're moving around. But you have to do a lot of the error handling that an orchestrated system would handle for you. So this is one of those things that comes with significant benefits at a significant cost. Do you have the organizational and development and operational maturity to pull it off? If you don't try it. And then continuous delivery. It really underpins everything. Because what we are trying to do is make deployments boring. Absolutely, positively boring. You want to celebrate the new features that your users have, not the fact that the CEO did not fall upon you from a great height because you crashed the systems yet again. And I don't care how good the run book is. No one is at their best at 3 o'clock on a Sunday morning. And they're gonna make a mistake. And so you want to look at continuous delivery as this enabler. Because you know, okay, the baseline is solid. So if something goes horribly wrong, I can isolate it. It's the same principle we've used with continuous integration for years. The smaller the change set is, the easier it is to figure out what the bug is, because you haven't changed all that much. Same principle here. So how might these practices evolve? I think they're going to evolve, but not radically. One of the interesting things that I've had discussions with people about is the Refactoring Databases book is all about relational databases. But Pramod has since then put out some literature around how you handle NoSQL databases. And the principle is just the same. What are the atomic changes that you're going to make, and break down whatever large-scale change you want into those atomic changes? What those individual refactorings are very different. But the principle remains the same. And as we get additional persistence mechanisms, we'll want to think about that in a different way too, because the problem of data migration being hard is not going to go away. AI-assisted tools might, in fact, give us more levers to help understand contract testing. We've had a few experiments across the Thoughtworks world with people using Gen AI tools, ChatGPT and Copilot, to try to understand legacy big balls of mud with varying degrees of success. I wouldn't say anything was wildly successful yet, but people have been able to extract some data flows and at least start to try to put together what in the world this thing is actually doing. Because as much as we would like to think that the Y2K incident solved all of those legacy problems, no, it didn't. There's still a whole lot of stuff out there that is just frightening. Again, this might go into the category of wishful thinking, but it's possible some of these tools might make choreography easier to pull off. There are still some of those error modes that you're still going to have to deal with, but it may be we can get advancements in tools that will at least handle some of them. I mean, if the orchestrator can handle them, intellectually we understand what has to happen. It's just that instead of all of the work being done by the orchestrator and the orchestrator knows everything that's going on, that logic has to be distributed. Like I say, this might fall into the category of wishful thinking, but I can always hope. And then I think we're going to continue to see new ideas on how we can bring things under the continuous delivery umbrella. Vendors are starting to recognize that they'll sell more of their tools if there's a way to script the deployment, as opposed to having to do the doodleware. But there are some other things, and when we start to think about, again, mixed reality, autonomous vehicles, what does it mean to do an over-the-air update to a car that's going down the road at 70 miles an hour? We've got to think differently about how we do some of these things. And so I think we're going to continue to see an evolution of our approach to continuous delivery, which is good, because I do think, again, as I said earlier, we're going to continue to see innovations in architecture, which just makes it a whole lot more fun to be involved in architecture. Things were pretty static for a while. Client server ruled the world way too long. So evolutionary architecture will evolve. And that shouldn't be that surprising, because the technology landscape that we're operating in is continually evolving. That's the whole reason we started thinking about this. When I started in this business back before fire was invented, you could understand the whole thing. You had a mainframe. You had JCL and DD Splat and all of those wonderful things. Even about 5 or even 10 years ago, Jim Highsmith, Mike Mason, and Neil Ford co-wrote an article about just how complicated the stack was. And that was before the stack got even more complicated than it was then. Let alone the rate of change. One of Neil's jokes, and I want to make sure he gets credit for this one, when we give this talk, he says, I will bet anybody in this room 100 of whatever their currency is, if you can tell me for sure what JavaScript framework you will be using in a year. No one has ever taken him up on that bet, because it probably hasn't been written yet. We've got so much innovation going on, which is exciting for allowing us to solve new problems. But it's pretty disorienting when you're trying to talk to your chief risk officer and explain to her why things aren't going to go horribly wrong. But I don't think it's likely to be a revolution. What might cause the revolution is something like quantum, because there are so many things we're going to have to think about differently. But as long as we are still working in our traditional von Neumann style architectures and our traditional sets of languages, even though we're getting new languages all the time, they're still in effectively the same language families that we've had for a very, very long time. So I think it's unlikely we're going to have a revolution anytime soon. There are probably going to continue to be new ilities. Now, maybe this, in part, will be splitting ilities into multiple facets. As I said, that list I put up didn't even have observability in it. I think as we do more and more testing in production and such, we'll probably have some new ilities. And who knows what AI is going to come up with. But, as I said at the beginning, my crystal ball is still broken. Who knows how right I am? I think there is some basis for all of the speculation, perhaps not the better code quality metrics, and perhaps not the maybe choreography will be easier. Those are probably the most speculative. I will admit, those do fit in the category of maybe that's wishful thinking. But I think the rest of them are pretty solidly grounded, because it is going to continue to evolve. And we have to live with the fact that our technology landscape is not going to stay still for us. And we might as well just accept it rather than trying to fight against it. So thank you very much.